Hello, Assalamualaikum. My name is Mohamad Farhan, and for our project presentation, we are presenting agriculture and farming analysis. Our group members are consist of me, Mohamad Farhan bin Muhammad Roslan, Dzul Danish, and one Muhammad Aqlan. Okay, today I'll be walking you through some key insight derived from an agriculture dataset. This dataset consists of 50 farms and captures various farming practices, input usage, and their effect on crop yield. We start by importing some essential libraries like pandas, seaborn, and numpy for data manipulation and visualization. Since the dataset contains only 50 rows, there's literally no missing data, which is a nice bonus. So instead of cleaning nulls and handling outliers, our main focus at this stage was renaming the column headers to make them easier to work with during analysis and plotting. Okay, moving on to 4A. In this part of the analysis, we explored the distribution of important numerical features such as farm area, fertilizer use, pesticide use, water usage, and yield. The data shows a wide range of farm sizes, from small to large, with varied input practices across different farms. Fertilizer and pesticide usage display multiple patterns, indicate that farmers adopt different approaches based on their needs. Water usage also varies greatly, possibly influenced by crop type and irrigation methods. Yield results Yield results are diverse with no single trend, suggesting that many factors interact to affect productivity. Overall, these findings encourage further analysis to identify which combination of inputs and practices can help improve yield outcome. Moving on to 4B, in this section, we explore the distribution of key categorical features in the dataset: crop type, irrigation type, soil type, and season. The analysis shows that cotton and barley are the most frequently recorded crops, while maize appears the least for irrigation method. While maize appear the least. For irrigation method, drip and flood are the most used indicating a preference toward controlled irrigation techniques. In terms of soil, clay, loamy, and sandy soils dominate the dataset, which reflect the typical soil type supporting agricultural activities in this steady area. Lastly, the Zaid season accounts for the highest number of crop records, suggesting a seasonal trend in planting and harvesting practices. This insight provide a foundational understanding of the dataset composition and help guide further analysis on crop performance and yield optimization. Thank you. I'll be passing to my next group member.
Okay, next, Assalamualaikum. So next we moving on the correlation heat map. So the correlation heat map reveals that farm area, fertilizer use, and water usage each show a slight positive correlation with yield. This means that generally larger farms increase fertilizer application and higher water usage are loosely linked to better crop yield. However, these correlations are relatively weak, suggesting that while these factors may contribute, they do not strongly predict yield on their own. A more notable finding is the positive correlation between pesticide use and water usage. This indicates that farms using more pesticide also tend to consume more water. So this is possibly due to more intensive or large-scale farming operations. So overall, the heat map highlights that agricultural yield is influenced by multiple interconnected factors rather than any single dominant variable. Next is the feature versus yield analysis. In this part, we analyze how yield varies according to different categories like crop type, irrigation method, soil type, and season. The box plots clearly show that yield is not evenly distributed. Some crops, irrigation types, and soil tend to produce higher yield than others. There's also variability in the yield for each category, meaning some conditions are more stable than others. This analysis helps us identify which factors might be more favorable for better agricultural performance. Next, I pass to my group member.
Okay, and then so for our modeling, in our modeling attempts, linear progression actually perform poorly, yielding a negative R score, which indicates that it performed worse than simply predicting the average yield for all test samples. When you apply a random forest model, the performance improves slightly with an R square of 0.03, showing only a minimal gain over linear regression. This suggests that neither model effectively captured the complex non-linear relationships in the data, and more advanced techniques or feature engineering may be needed to improve the predictive accuracy. And then for the feature, the most important feature from using random forest, we get that the top five most is fertilizer use, farm area, water usage, and pesticide use, and crop type cotton. For fertilizer use came out as the most impactful, as it indicates a strong positive relationship between fertilizer and crop productivity. For the farm area, uh, it suggests that larger farms might be more productive due to scale or resource availability. Water usage also played a major role, reinforcing the importance of effective irrigation, while pesticide use had a noticeable but smaller impact, showing that pest control does help, though it is not as critical as the top three. Finally, the crop type cotton stood out among the categorical features, possibly due to its higher yield per input unit. Overall, the model relies more heavily on numerical inputs rather than categorical variables. It is highlighting the importance of quantifiable resource usage in predicting the yield. Thank you. That's all for us.